so let's take a look. It says, derive a formula for the, okay, it should say the sum of the first n terms of an arithmetic sequence if the first term of the sequence is a and the common difference is d. Okay, so remember guys, with an arithmetic sequence, we're going to have term 1, term 2, term 3, etc., all the way up to term n. Okay, so hopefully you grasp that. The term below term n is term n minus 1. I hope you agree with me. If, let's say, I went to 10 terms, then this would be term of 10 minus 1. So I get term 9, okay? That's purely what that means over there. So then it says the first term, so A always represents term 1, okay? And the common difference is D. So that means that between each and every one of these terms, there is the difference D, okay? So even between the second to last and last term, there is a constant difference of D. That is what that means, okay? So if you look here, in terms of this, term 1 is always A. Term 2, we can write as A plus D, okay? Because remember, if I add D to A, I get term 2. If I want to write term 3 in terms of the first term, I hope you agree that it's A plus 2D. And all the way to, let's say, term n is our last term, okay? For argument's sake in this derivation, let's say it's the last term. This means that this term here is the last term minus D. I hope you agree with me, okay? And then if I say term of n minus 2, I will get L minus 2D, where L is the last term, okay? But bear in mind, guys, the last term is also given to us by Tn. And what is Tn in an arithmetic sequence? It is A plus n minus 1 multiplied by D. Okay, so Tn, the last term, and this formula, all exactly the same thing. Okay, so very important. So now it's saying, if I want to take the sum of all of these, Sn, the sum of all the terms to the nth term, okay, I'm going to say term 1 plus term 2 plus term 3 all the way to term of n minus 2, which is the last term, minus 2d, plus the last term minus d, plus the last term, because we are going to n. Remember, the last term corresponds with Tn. Okay, so if I say that sum, that's cool. In here are all the missing terms that I didn't write out. Okay. Now, some bright spark decided, okay, to derive a formula for all of this, let me write that whole sum backwards. So, if I start with the last term, okay, I can say L plus, then I go to the next term, L minus D, plus L minus 2D, all the way to, should be a plus in there, A plus 2D, plus A plus D, plus the first term all the way at the end, okay? The reason for this being, if I do that, and I add these two things together, okay? I hope you agree that one Sn plus another Sn is going to give me two Sns. So, two sums to the nth term is going to equal. Now, if you look here, if I say D over here, plus negative D, D plus negative D is the same as saying D minus D, which is 0. So this D is going to cancel out with that negative D, as is this 2D going to cancel out with that negative 2D. And then at some stage we'll have a 3D and a negative 3, and they will cancel out all the way up to the end where I have negative 2D plus 2D, which is 0. Negative D plus D, which is 0. So what I'm left with is all of these A terms, okay? And A is going to go all the way to the end of our sequence. We're going to have n numbers of the first term I hope you agree with me, okay? And what is left in our second sequence is L, L, L in every term all the way to the end. Okay, so we're going to have n numbers of L. Okay, so if I expand on this, 2Sn is equal to, if I take out n as a common factor in both of those, I can say n into A plus L. Okay? Then, to get Sn on its own, if I divide both sides by 2, I'm going to get that Sn is equal to n over 2 into A plus L. Now, this is definitely not our complete Sn formula. Remember, right at the beginning, we said if we want to simplify and use L as our last term, we must remember that it is Tn, and that for an arithmetic sequence is this whole general term. So if I go and resubstitute that into my sum formula, I'm going to get that Sn is equal to n over 2 into A plus, remember our last term is that general term, A plus n minus 1 multiplied by d. Okay, so now we just simplify. N is equal to, or Sn is equal to n over 2 into A plus A is 2A plus n minus 1 d. Remember, that is the sum of an arithmetic sequence all the way to term n. Okay, so that is how you derive it, guys. It is a very simple proof. Learn it off by heart, but make sure you understand where all of this stuff is coming from, and it'll make so much more sense for you to derive that formula. Okay, guys, so that is the end of question 3.